Hello everyone, welcome back to our channel Electro Study. This is lecture series 9, non-conventional energy sources dealing with solar space cooling of buildings. Come, let's go into the video. Please do like, share, subscribe and comment. So what is cooling, space cooling? So this is an outline diagram which completely describes how the solar energy is collected through arrays and how it is stored, how it is condensed, and how the energy is being or electricity is being generated through generator. What are the two parts of this complete building space? All these are totally given in this diagram. We'll see the subtopics, sub important topics which we have to focus on it. So generally the essential components of the cooler, so here you can see one is solar collector and storage. So this complete part is solar collector and storage, and this complete is absorption air conditioner. So for that we have some essential components of cooler, so which is nothing but generator, condenser, evaporator, heat exchanger and absorber. So these are the five main and essential components of the cooler that we have to focus on when we are calculating the space of the building, cooling of the building. So now this system part is divided into two. That is nothing but the solar collector and storage, solar absorber, air conditioner and auxiliary heating. So that is what we have seen here. So now here when you see the diagram, see the operation of the air conditioner. So generally the operation of the air conditioner with flat plate collector and storage system, it is the common approaches of the solar cooling. So in essence of the cooling, the generator here the generator is made as an absorption cooler which is supplied with heat by a fluid. So the collector, it is collecting the solar energy, it is storing, and this is passed on to the generator, and the generator acts as an absorption cooler. Now here you can see the heat is supplied to a solution of a refrigerant and the absorbent in the generator. So where the refrigerant inside this generator, it will distill out all the absorbent fluid. So the refrigerator is then what happens? It goes to the condenser. So the refrigerator is condensed and goes through a pressure reducing valve to evaporator. So where it operates and cools the complete air or the water. So now this refrigerant vapor, what happens? It is following through the cold water, right? So this refrigerant vapor goes to the absorber, and now the vapor goes to the absorber where it comes in contact with the solution. So here you can see a heat exchanger. Heat exchanger is nothing but it is used for sensible heat recovery, or it will greatly improve the cooler's performance. So from the point of view, as we are using conventional energy sources, so there is a single performance rating for cooling process. So the amount of cooling of energy that is required, we totally calculate only that. So for the solar operation, there are two additional factors. That is the temperature required in the solar collector. So here is the solar collector where the temperature at the solar collector, what happens is it will observe as the solar processor or transient in their operation. That is the energy ratios and temperature will keep on varying. It will not be the same because the solar radiation that is falling across the arrays, what happens? It is not at the same intensity it is falling on. So for pumping to more absorbent solution, we may use some low pressure systems like lithium bromide water system. So this is the main system that we are using, which requires some water cooling of the absorber and the condenser. So here that is nothing but the lithium bromide and H2O. This is the complete block diagram of that water cooling absorber and condenser. So now the condensed water here, the cooling space is there, right? So the coolers is mostly used in experiments like lithium bromide water machines, and the pressure in the condenser. So here is the condenser. There is a pressure created when the generator is pushing some energy to the condenser. So the pressure in the condenser and the generator is fixed largely by the temperature that drops across the heat transfer surface in the generator and the condenser. So now after the condenser comes out, there is a pressure that is coming out from the condenser. The pressure in the evaporator and the absorber will be fixed by the temperature of the cooling fluid, and thus the generator temperature will be kept at the minimum permissible limits, like how the flat plate collector is functioning. You will have a small tubes at the end of the flat plate collector which regulates the complete heat that inside the flat plate collector. So here completely we can tell that the common practice in the solar experiments will be the usage of water cooled absorbers and condenser, so which in turn the absorber and the condenser will cool the water that is generated from the generator pushed to the condenser, and you can it requires a cooling water. So the absorber and the condenser which will in turn require a cooling water. So this is nothing but the outline of a lithium bromide water cooling system, and you can use any kind of chemicals to experiment this cooling system. Stay tuned for more information. Thank you.